Have you ever faced a situation where a function in your code is slowing down your program unexpectedly? It can be incredibly frustrating, especially when you need that performance boost. Today, we're diving into a specific issue with the exponential function in C and how to tackle it. I totally get it. You're not alone in this struggle. Many developers have encountered performance issues due to unexpected behavior in mathematical functions. It's a common challenge in programming, especially when dealing with floating-point arithmetic. Here's the specific situation we're addressing. One user reported that the GCC implementation of the exponential function is causing significant slowdowns in their program. They found that when the input is nearly halfway between two double values, the performance drops drastically. Sound familiar? Let's explore this together. So what's happening here? The user is encountering a situation where the exponential function's correct rounding is actually hindering performance. This is particularly true when the input is of a specific form, leading to slower computations. Let's break this down. And stick around. By the end of this video, I'll share a workaround that can help you avoid these performance pitfalls when using the exponential function. To address the user's concern about the performance of the XP function, we can explore using an alternative implementation that sacrifices some precision for speed. The user can look for libraries or functions that provide approximate results. Next, the user can implement a custom approximation for the XP function. This can be done using a polynomial approximation or a lookup table for specific ranges of input values. Additionally, the user should consider adjusting the precision requirements based on the application's needs. If exact results are not critical, they can set a threshold for acceptable error. Finally, the user should benchmark the performance of their new implementation against the standard XP function. This will help determine if the trade-off between speed and precision meets their requirements. Fun fact, did you know that the exponential function is one of the most important functions in mathematics? It appears in everything from compound interest to population growth. But in programming, it can sometimes be a double-edged sword. Now let's look at the answers provided by other users. An alternative approach suggests using a Taylor expansion for small arguments in the XP function. The user points out that for very small values, this method can provide results quickly without the overhead of correct rounding. The user also modified the original test program to compare the performance of XP and XPM1. They found that using XPM1 significantly reduced computation time, especially for larger numbers of trials. That's it for that answer. Let's take a look at another one. In response to the issue with the XP function, this user explored EOF's TREQ algorithm for binary tree summation. They found that TREQ produced the same results as a plain sum using XP, rather than the expected more accurate results from XPM1. To clarify the behavior of TREQ, they created a simpler test program to evaluate its performance against a binary tree summation function they developed, called binTreeSum. The results showed that while TREQ worked correctly, it did not achieve the intended binary tree summation improvement, especially in cases with small epsilon values. Here's the workaround I promised. By implementing a custom version of the exponential function or using approximations, you can significantly improve performance without sacrificing too much accuracy. This can save you a lot of time in your computations. And there you have it. You now have strategies to tackle performance issues with the exponential function in C. Remember, optimizing your code can lead to significant improvements. If you found this video helpful, don't forget to subscribe for more tips and tricks.